So today we are going to continue with the first chapter on Math 135, and we are going to start here with variables and types of data. First, we want to define what variables are. Variable is a characteristic or attribute that can assume different values. If you remember from the last class, when we talk about the variables, variables are things like age or height or GPA. These are the variables because these variables uh, can be characterized by different values, or they can assume different values. For example, when I talk about the age of my student in the class, it can be 18 years, 22 years, 25 years, and so on. You have different values there. Or if I talk about GPA, average GPA that you have so far at CCA, maybe 3.5, 3.7, 4.0, and so on. So those are variables. Now, variables whose values are determined by chance, they are called the random variables, and we'll be using random variables in probability later on. We are going to look at these variables in a little bit detail. Variables are of two types, the qualitative variable and quantitative variable. So first, let's go over the qualitative variables. When I say qualitative variables, these are also called the categorical variables. It will categorize the data. So qualitative variables, it categorizes the data. That's why they are called the qualitative or categorical variables, are the variables that have distinct categories according to some characteristic or attribute. For example, when you say, or when I say nature of origin, that is a variable. And if I want to collect the data about nature of origin, it will categorize the data. Okay, this group of people are from Canada, their nature, and maybe the nation of origin instead, maybe Canada, let's say, or maybe some other country. If it is a nation of origin, let's think of nation of origin here. Number on the baseball player's jersey. So if you see the numbers on the player's jersey, but it will just characterize the position of the player. Those numbers on the back of the jersey, we don't add, subtract, multiply, or divide. So that is purely categorical. Similarly, phone number. We don't use phone number for any kind of addition, subtraction, multiplication, or division. Phone numbers are just the category of numbers. They are not the pure number to add, subtract, multiply, or divide. Similarly, student ID, it is also a number. For example, S followed by whatever number you have, the S number, that's your student ID number. We don't add, subtract, multiply, or divide. That is categorical. It categorizes the student. That's why it is categorical variable or qualitative variable. Religious preference, what religion you prefer. If we classify a group of student or group of people based on religion, we'll have different categories of people. So this is also the categorical variable. Geographic location, say for example, North American country, South American country, Asian country, African country. So if I'm looking at a geographical location, it also categorizes the data. Similarly, gender, it also categorizes the data. Male, female, other genders will have the group of people based on gender. So these are all the examples of the qualitative or categorical variables. Very important thing for you to know later on when you solve the problems towards the end of this class. In your note catcher, you can see there are examples there. When you solve those examples, you need to know these things. What is qualitative variable or categorical variable? What are the examples? This is exactly what you are doing in those examples. That's why you need to know the detail of these type of variables. Next one is called the quantitative variable. Quantitative variable, they are also called the numerical variables because these variables involve pure numbers. So whenever you see pure numbers, which can be, when I say pure numbers, these are the numbers which can be added, subtracted, multiplied, and divided, then the variables are called the numerical variable or quantitative variables. So numerical or quantitative variables are that which can be counted or measured. For example, number of children in a family. Let's say there are 5, so you can count. Grams of carbohydrate in a packet of cereal. How many grams of carbohydrate are there in a packet of cereal? That's a pure number. A value of a house, 300,000 maybe. So that's the value of the house. It is a pure number. So it is quantitative. For example, age. What is your age? 27 years. 27 is a pure number. So that is the quantitative variable. or numerical variable. Similarly, height, I am 5'7". If I say that, that is numerical variable. Similarly, weight, what is your weight? That is the numerical variable. You represent that by a number. Body temperature, what is your body temperature right now? 98°F, a pure number. So that is also the numerical variable. So here in this slide, we defined variable and we saw that the variables are of two types. Qualitative, they are also called the categorical, and numerical or quantitative variables. So those are the two different types of variables. So we have seen variables are of two types, qualitative variable and quantitative variable. Now, quantitative variable or the numerical variables, the numbers, they can be of two types, discrete variable and continuous variable. Discrete and continuous, these are the two types of quantitative variables. When we say discrete variable, it will not take decimal value. In discrete variable, there are no decimal values or fraction. Those are purely the counting numbers. Discrete variables are those quantity or variables that assume the value that can be counted or measured. For example, number of trees in randomly selected acre of fruit garden. So if you are asked to find the number of trees in a selected acre of a fruit garden, you'll count how many trees are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there are 120 trees. You will not come up with something like 120.7 trees, nothing like that. No decimal point there. Similarly, points scored in a basketball game, it's also a whole number. There are no decimal involved there. Number of children in a family, maybe 5, not 5.6. There is no decimal involved there, so discrete variable. Number of students in a classroom, or how many students are currently in this Zoom classroom. I have 13 students. So that is exact whole number. That is discrete variable. Number of calls received by a call center on one day. How many calls do they receive on one day? Maybe 720 calls. No decimals. Okay, whole number. So discrete variables, these are the quantitative variables which involves pure number, pure counting number. It does not involve any decimal value. Whereas when we talk about the continuous variable, they can take any values like decimal values and fractional values also. So continuous variables are those quantitative variables that can assume infinite number between two specific values. They can include fraction and decimal. For example, when we talk about volume of water lost in an hour through a leak in a water tank, how much water is leaking through a tank? Maybe it can be 2.3 liters or it can be 7.3 liters. It can take decimal value. Temperature on a randomly selected day in Aurora. If I want to measure current temperature, maybe it is 77.3 degrees. It can be 77.4 degrees Fahrenheit. It can be 77.8 degree Fahrenheit and so on. It can take decimal values. So it is continuous variable. Similarly, your internet connection in the speed of kilobyte per second. What is my upload speed? If I want to measure that, maybe it is 23.7 kilobyte per second, or it is 38.2 kilobyte per second. It can take the decimal value. So in that case, we say that the internet speed connection in kilobyte per second is continuous variable. Similarly, the weight of football player, if we are measuring the weight of football player, maybe you have 120.3 pounds. So decimal is possible there. So that is continuous variable. So those quantitative variables, which can take only whole number values, they are called the discrete variable. And if they can take the fraction or decimal value, they are called the continuous variable. So by looking at the nature of the quantitative variable, you must be able to classify them as discrete and continuous variable. Level of measurement. Data can be classified into 4 level of measurement. Now, if we want to classify the data, see, the last one, when we talk about the qualitative, quantitative, discrete, and random variables, those are the variables. Now, here we are classifying the data. You know, the data are the value associated with the variables. So if age is the variable, the data is like 18 years, 20 years, and so on. Now we can classify data, okay? We can classify data into 4 level of measurements. And those four levels of measurements are called nominal, ordinal, interval, and ratio. These are four levels of measurements. Now we are going to understand each of these in detail. The first one, when I say nominal level of measurement, this measurement is purely qualitative. It does not involve pure number. If you see numbers there, you cannot add, subtract, multiply, or divide these numbers. So nominal level of measurement are qualitative, and mathematical computation cannot be made. If you see numbers there, you cannot use them as a pure number. For example, you can see nominal level of measurement are categorical using names. So you may have a name. If you see a name of something, that is nominal level of measurement. If you see label, that is also the nominal level of measurement. If you see qualities, then it is also called the nominal level of measurement. Examples here, the first one, nation of origin, where you are from. I am from Canada. I am from China. I am from Mexico, you know. So when I'm just giving these country as the name, this is just the name as suggested here. Okay, it is just the name. So this is purely nominal. Similarly, it can be label. Like if I'm classifying a group of people based on that eye color, so you can say that eye color is the label that I'm using. So it is nominal. Similarly, zip code, that is also the label given to particular place. Although your zip code is maybe 80011, the zip code for CCA, that is nominal because we don't add, subtract, multiply, or divide zip code. Similarly, gender, it's also nominal. Political affiliation, okay? I am a Republican, I am Democrat, or I'm non-affiliated. Political affiliation, that's also nominal. Nationality, what is your nationality? When I ask for that, that is also nominal. You are not giving any pure number. So when we say nominal level of measurement, the data contains, if even if it contains number, these are not the pure numbers. So the nominal level of measurement are purely qualitative or categorical. So categorical data, they fall here. That is first one, nominal. Next one is ordinal. When we say ordinal level of measurement, ordinal level of measurement classifies data into categories that can be ranked. Now, you may see numbers, but the numbers are used here as rank, and the difference is not possible to measure. For example, if you see movie rating from 1 through 5, now see, I'm talking about the rating or rank, that is ordinal level of measurement. Okay, always remember, in nominal, in the first one, nominal, it is purely categorical. Whereas in ordinal, we talk about ranking, and you cannot find the difference. You cannot find the difference, no difference. That is a characteristic. So students grade A, B, C, D, E, F, that is the ranking. So that's why it is ordinal. Judging, like you are judging a show and you are giving the position like first, second, third, and so on. So this is also the ranking, so ordinal. Rating scale, like poor performance, good performance, excellent performance. This is also the rating, so ordinal. Ranking of football player. So definitely this is a ranking, so it is ordinal. So in this slide, what you saw is we talk about two levels of measurement. The first one is nominal. When I say nominal, it is purely categorical data. It is purely categorical data. Even if it involves number, it is not a pure number. Next one, we talk about the ordinal. Ordinal level of measurement talks about ranking. Okay, there can be a ranking or ratings or things like grade, first, second, third, poor, good, excellent. So this is all ordinal level of measurement. Third level of measurement is interval. When we talk about interval level of measurement, it also ranks data, but the difference between the unit of measurement is possible. Here, the difference is possible, but if it has any zero involved, zero has no meaning. So this is quite tricky. Sometimes we get confused with interval and ordinal. Ordinal is just a ranking, but this one is a little bit different from ranking. Here you can see, for example, your IQ score. Your IQ score has a certain range. It will go from certain number up to that particular number. But here, if you are getting more number over there, you are performing well. You have better IQ than the other one. And also we can find the difference, how much more you got. Like ACT score. If we compare the ACT score of two students, one will be higher than other. How much more? We can find that. Similarly, temperature. This is very, very big example of the interval level of measurement. You can even highlight in your note catcher. Temperature is interval level of measurement. Similarly, time of the day in military time. That is also the interval level of measurement. And the last one, year of birth of college professor. When I was born, 1942 maybe, just kidding. But you know, that number can be interval when you are born. If you think of the year you are born, that number is the interval level of measurement, because the interval of 12 months is a year. You can clearly see there is an interval there. That's why this is the interval level of measurement. So don't get confused between these two, ordinal and interval. Ordinal involve ranking, but this one, you can find the difference between the values, but there is no meaning of zero. Okay, if somebody got zero in ACT, meaning of that is maybe they have not done test. I don't know. Actually, there is no meaning on that. Nobody will get zero on ACT. I didn't see that. Next one is the ratio level of measurement. You can see here. Now, what we have studied in the beginning, when we talk about the nominal level of measurement, the nominal level of measurement is purely categorical, but this one, ratio level of measurement, is purely numerical. All pure numerical data fall here. So ratio level of measurement possesses all characteristic of interval and true zero exist. Meaning of that is, this is purely numerical. If you look at the examples here, for example, volume of water in a tank. How much water is there in a tank? 500 liters. See, a pure number. So ratio. Value of a house, $300,000. So that is a pure number, ratio. Your height, 5.7. Although it takes decimal, you know, it is a pure numerical data. That's why this is ratio. Your weight or weight of something, a pure number, ratio. Time. Now, don't get confused with this one. Time of the day in military time is interval. But if I say time, meaning of that is how long it takes. Like how long it will take me to complete a quiz, maybe 15 minutes. I'm talking about time like that over here. Similarly, salary. What is your salary? How much you are making every month? $3,000, a pure number, a ratio. What is your age? I am 72 years old. That is a pure number, so it is a ratio. So we must be able to look at the data and then classify data as nominal, ordinal, interval, and ratio. One more time, in nominal, you have purely categorical data. In ratio, you have purely numerical data. Ordinal has ranking, and all other will fall as an interval. Data collection and sampling techniques. Gathering information about entire population often costs too much or virtually impossible. So if I want to collect data about everything under consideration, for example, if I want to know the average age of students at CCA, it's kind of impossible for me to go to every single student and ask question and collect the data. So what we do is, instead we use a sample of the population. Instead of asking every student at CCA, we sample, or we take a small group of students, or we ask a small group of students at CCA to find their average age. And we can use that information to predict about the whole population. So whenever we are performing any statistical study, instead of using the whole population, we use sample. A sample must have few characteristics. The first one is, a sample should have some characteristic, same characteristic as population, and is representing. So whenever we are selecting a sample, the sample must be representative of the population. It must represent the population. Otherwise, your information will be wrong. Next one, must statistician use various methods of random sampling to achieve the goal? Most widely used sampling technique is random sampling technique. That is the meaning of that. And it works 90% of the time. But in wider view, there are 4 different ways of collection of data or sampling technique, and they are called the random sampling technique, stratified sampling technique, systematic sampling technique, and clustered sampling technique. So sampling techniques, there are 4 types: random, stratified, systematic, and clustered. Now what we are going to do in next slide is we are going to go over each of these, and we are going to understand the technique in each of these, because later on when you see the example, you'll be given a situation, and by reading the situation you must be able to label it as a random sample, stratified sample, systematic sample, or clustered sample. So the first one here is the random sampling technique, okay, and it is also called the simple random sampling. Let's find out what we do here. Simple random sample is the process of using chance to select individual from a population to be included in the sample. For example, we have a population here. From here, we select some people randomly, okay? So we are selecting the individual randomly from there. In order to obtain a sample of size n, so small size n, out of a big population of size uppercase n, we use table of random sample. This is the old method. They use the table of random sample to do that. Or they also use some software to generate the random number. So let me show you how you can use a software, that is our calculator in our case, to generate the random number. Okay, here in this calculator, I'm going to show you how to generate random number. For example, you have 20 students in a group, or 20 students are there in a class. And what I am going to do is I need to pick only 5 students. So which 5 students I need to pick? What I can do is I can number the student. I can count the student from the first row and give them a number like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, now I have a number associated with each student. Then after that, what I can do is I can go to, I can use calculator to get 5 students. So go to math, and then after we press math, we scroll across to probability here. We go to probability. Now probability is selected. Under probability, we select this one, number 8, where it says random integer, no repeat. I want 5 students without repeating, so I'm going to select 8. Then I need the lower value. So I have a student from 1 through 20. So lower value is 1. Upper value is 20. That is what I have. From 1 through 20, that is the number of students that I have in the class. I need a sample of size 5. So 5 is the sample size. And then we go here and paste. So once the paste is highlighted, enter. So it goes here. If your calculator just gives random integer no repeat, then inside the parenthesis you can type this 1, then 20, then 5. Okay, then hit enter. Now you know which 5 student to select. We are selecting the student number 19. I have the calculator set to 4 decimal places. That's why it is showing this 0. So I'm selecting the student in 19th position, student number 19, student number 3, student number 11. Then let's see, after 11, I have student number 9 and student number 15. So I got 5 students, 15, 9, 11, 15, 9, 11, 3, and 19. So this is how you can use software to generate the random number and then select a random sample out of that. Stratified sampling. First, we are going to look at the definition and we're going to talk about the technique here. When you say stratified sample, it is obtained by separating the population into non-overlapping group called strata and then obtain a sample, okay, using the random sampling technique from each stratum. So one more time, look here. Stratified sample is obtained by separating the population into non-overlapping group called strata and then obtain a simple random sample from each stratum. So we have a population, for example, here. Say that this is the entire population in our country. Then we divide the population into smaller groups like this. There are only two groups shown here. It can be even more than that. And these groups are called strata, but they must have the non-overlapping characteristic. For example, if I talk about the political affiliation, maybe the first group represent the Republican, those who are in Republican. Second group may be Democrat. And maybe there is also a third group, say, for example, suppose they are non-affiliated. They are not affiliated to any party. So suppose I have three groups and they are non-overlapping. The Republican cannot be Democrat, or Democrat cannot be Republican, or non-affiliated. That's the meaning of that. So everyone here has the same characteristic. Everyone here has the same characteristic. Everyone here non-affiliated, same. Then from here, we select few, whatever number we want, using random sampling technique. That is the technique that we studied in the previous one. So randomly, few of them will be picked from here. Randomly, few of them will be picked from the second. Randomly, few of them will be picked from the third. So here we have a group of people, and this group is the sample. So sample obtained like that is called the stratified sample. Next example here. Let's see, here we are selecting the houses. For example, in a community, we are creating a group of houses. This is first group, this is second group, this is third group called strata. And how we group this, the first one represents low income community here. This one is middle income community. This is the high income community. We selected houses in three different community. From first community, we are randomly selecting. From the first community, we are randomly selecting two houses. From second one, that is from middle income, we are randomly selecting two houses. And from here, we are randomly selecting two houses. And the group of those 6 houses is our sample called stratified sample. So this is the technique involved in stratified sampling. Systematic sampling. Systematic sampling is obtained by selecting kth individual from the population. So this is the key here. Every kth element. For example, here I have the houses. You can see there are a lot of houses here. You pick the first house randomly, any house from this line. Okay? Pick any house from this line randomly. So first is your own choice. So for example, I select this one. Then after that, you can select every third house or every fourth house or every fifth house or every seventh house and so on. For example, the first house selected is this one. If I'm selecting every third house, first, second, third, this is selected. Then every third house, first, second, third, this is selected. Then third house, first, second, third, this is selected. First, second, third, this is selected. First, second, there is no third. So how many I'm able to select? You can see 1, 2, 3, 4, 5. So this technique is called the systematic sampling. So in systematic sampling, we pick the first one randomly. One more time, we pick the first one randomly, and then we pick every kth individual. It can be every third one, every fifth one, every seventh one, every 10th one, and so on. So that process of sampling is called the systematic sampling. It is not difficult, it's quite easy. Clustered sampling. Clustered sample is obtained by selecting individual within a randomly selected collection of individual. So for example, in the clustered sampling, what we do is we make the clustered, okay, we make little groups. Let me give you a good example here. There are so many students at CCA. Now, right now, many group of students are taking classes You are taking class with me, and the group of students is taking class with some other professor. So there are so many students taking class right now, starting at 8. Then we consider this group or class as a cluster. Okay, there are several clustered taking class right now. In clustered sampling, what we do is we pick the whole cluster. So in the sampling technique, although we have this small group of classes going on, now if I need a group of, let's say, 25 students, I can pick this cluster, all of my students from here, and maybe all biology 1 student who are taking a class right now. Then if I combine these two groups together, I get the sample. So in cluster sampling, what we do is we have the cluster, or we divide the population into cluster if possible, or we look at the clustered which are already formed. Like this class is a cluster. Somebody is taking college algebra right now, that's a cluster. Somebody is taking chemistry 1, that's a cluster. Somebody is taking biology 1, that's a cluster. So there are so many clusters already formed. So from this cluster, we pick few. How many students I want? Maybe 25. So 13 students from my class. It's a group of 13 students that I have right now. And maybe there are 12 students taking college algebra somewhere right now. If I pick these two together, I have a group of 25 students. So this sampling technique is called the cluster sampling technique. Errors in sampling. When I say errors in sampling, I'm talking about the mistakes that might have happened when we are doing sampling. So sampling error is the first one. Sampling error is the difference between the result obtained from the sample and the result obtained from the population from which the sample was selected. So if I want to find the average age of the students at CCA, and if I use a sample, I may get the average age of a student at CCA is 22 years. But if I go into the real data somehow, and then get the information from the administrator, maybe it is like 23. So there is a difference there. So that difference is because of the sampling error. So sampling error is the difference between the result obtained from sample and result obtained from population from which the sample was selected. Sampling error occur if the sample gives incomplete information about the population. This happens if the sample is non-representative of the population, or if the sample does not represent the population, which is the same thing, incomplete information, or it does not represent the whole population. So that is the first type of error, the sampling error. Next one is non-sampling error. It occurs when the data are obtained with some error, erroneously, or sample is biased or non-representative. You know that you need to collect the data, you need a 30 student from CCA, instead of doing a proper sampling technique. What you're doing is you just collect the data from your friends, who is quite easily accessible to you. So you make a big mistake in collection of a data. You didn't follow a strict measure in collecting the data. So that is called the non-sampling error, which is because of errorly collecting the data or because of the biasness. So non-sampling error, if sampling technique is a convenient sampling. So when I say convenient sampling, you are sampling at your own choice. Instead of using a random sampling technique, you have 5 friends around your table, you are just collecting the data from them at your convenience. It also occurs due to data entry error. Sometimes, even if you do the sampling properly, when you are recording the data, you may enter wrong data. For example, somebody was saying 25, I'm 25 years old. You accidentally wrote 52. In that case, your result will be different. So that is called the data entry error. So that type of error that occurs while sampling, it is called the non-sampling error. Here we'll talk about observational and experimental studies. There are 2 types of statistical studies that we are going to observe here, or we are going to explore here. The first one is the observational study. When I say observational study, researcher is just observing what is going on. He is not manipulating anything. He's just looking at it and recording the data. For example, if I want to study the temperature change in the month of September, then what I'll do is I'll start recording the temperature from the 1st of September till the last day of the September. So that is observational study. Okay. Or if I want to make an observational study on how the students' grade are affected by their absences in the class, what I'll do is I'll just look at the record, like how many students are absent, how many times, and how are their grades. I'm not going to say anything to the student, but I'm just recording the data. Observational study. So pure observation. An observational study measures the value of the response variable without attempting to influence the value of either the response or explanatory variables. So here, researchers observe the behavior of the individual without influencing them. You'll not do anything, you'll just observe. Researcher merely observe what is happening or what has happened in the past. Sometimes he can also refer back to the data from the past without doing anything. He just collect the data and then use that data to draw the conclusion on the observation. Observational study do not allow researcher to claim. He don't claim anything. He just say this is what it is. The average temperature in the month of September in Aurora, Colorado is 77 degrees centigrade by observation. That is it. He is not going to do anything. He is not going to claim about the causation, what causes these. If he finds that the average temperature in the month of September is around 90 degree, he is not going to explain why it happened because this is just the observation. Okay, he's not going to explain the cause, but he's just going to give you the association. I observed for the whole month. This is what I got. That is called the observational study. Experimental study. When we say experimental study, in experimental study, the researcher manipulates one of the variables and try to determine how manipulation influenced the variable. For example, I was talking about the number of days the student remain absent in a semester and their grade. Definitely what we'll find is if a student is absent for more number of days, their performance will not be good. Their grade will be low. Okay, that's what we get from the observation. Now in experimental study, what he can do is he can ask the student not to remain absent for many days. So the number of days the students are absent will be reduced. That is, he is manipulating the variable. He is not letting a student to remain absent. And then when you look at the grades later on, the grades will be improved. Okay, so that is the experimental study. In the experimental study, there are a few things that we need to know. Independent or explanatory variable, which is also called the X value when you try to draw the graph, okay, is an experimental study that one is the one that is being manipulated. So normally in experimental study, they try to change the input value or the independent or explanatory variable. So because of that, the one I was explaining before was reducing the number of absences. That is, you are reducing the X value. When you reduce the X value, your output was great, the Y value, that will increase. The resultant variable, it is also called the dependent variable, which is Y variable, or outcome, like in function. So when you make change in the independent variable or explanatory variable or X variable, you'll see change in the dependent or the outcome variable. They always make change in the independent variable. If a researcher assign individual in a study to a certain group, like now what they are doing is they are making vaccine for COVID-19 and they are assigning certain individual for the trial. Okay, intentionally change the value of the explanatory variable, then record the value of the response variable for each group. This is called a design experiment. So they are testing on vaccine right now. So that is the designed experiment. They're giving this vaccine to certain group of people who are participating, and then they are looking for the results. This type of experiment is called the designed experiment. And once the designed experiment is completed, the result of the designed experiment can be broadly analyzed and we can make the prediction about how it will work and they can be brought to public. Two more things at the end of the experimental study, two more terms here. Co-founding or lurking variables is the one that influence the outcome or dependent variable. If there is influence on the outcome or the dependent variable, then we say those variables are called the co-founding or lurking variable. Okay, outcome or dependent variable, but was not separated from the independent variable. They must be dependent on the independent variable, but the influence is made on these two variables. So co-founding or lurking variable is one that influence the outcome. Here, the influence is on the outcome variable or the dependent variable. In general, listen here, in general, the changes are made in independent or explanatory variable. If the changes are made on dependent or outcome variable, in that case, those variables are called co-founding or lurking variable. That is the meaning of that.